So far we've talked about, in the first two videos, or the nature of the oceans in terms of their general characteristics, and some of the really early exploration of, the more ancient Europeans and the Polynesians. The last little bit of discovery we have to talk about is probably the one you're more familiar with, which was the quote-unquote age of discovery in Europe with the 1492, Columbus sailed the ocean blue. These guys were really motivated by trade. A lot of exploration of the oceans due to trade. Prince Henry the Navigator really wanted to get to Asia. Now, they'd been going to Asia overland. If you know your Marco Polo, that was about 200 years before. It took him 27 years to go to Asia and back. Now, granted, there were things delaying him, but an overland route was just not a money-making scheme, and the people in Europe wanted to trade in Asia bad. So they wanted another route. So Prince Henry the Navigator of Portugal started looking around for somebody who would go sail off the edges of the map and find a route. They knew that this notion that people thought the Earth was flat, there's some debate about that, but sailors knew for sure that it wasn't. They knew this because when they would look out the little, telescopy things they had, they would see the crow's nest and the sails of the ship first, which suggested that the Earth had a curve to it, or you would have seen the whole ship at the same time. Anyway, so he wanted them to sail across what they thought was the ocean to get to Asia. So he signed up Christopher Columbus. Christopher Columbus, he sailed to the New World. He had no idea where he was. He thought he was in India. He was actually in the Caribbean. And we can get debate about the plagues and diseases and all sorts of horrible things that ensued after that. But he was the first person to be in the Caribbean. Ironically, he was, even though we call it the Americas, he never set foot on North America. Christopher Columbus turned around and went home. John Cabot was what we consider the first European in North America, such as it is, and he came 5 years later. Magellan, or when I grew up in the Philippines, we called him Magallanes. He gets all the credit for circumnavigating the globe, but he didn't make it. So he was killed in 1521 in the Philippines. He was actually killed in Eden. This is a reoccurring theme you'll see. He was killed by a local guy named Lapu-Lapu because they didn't understand royalty or have much respect for that, and he was kind of caught up in a tribal war between two different islands in the Philippines. It's probably more than you need to know. But some of the members of his crew completed the circumnavigation in 1522, and he gets the credit, at least for starting the first trip that circumnavigated the globe. And this took a number of years. These voyages, particularly of Columbus and Magellan, in terms of Spain, really upped Spain's value in Europe. Because of these voyages, they were able to get massive amounts of gold from the New World, especially from the Incas and the Mayans. And the dominance of Spain's armada was only when the English really built their own. And you probably know about the wars from that time. So Spain really had a good run there. This picture shows you the routes of Columbus and Magellan. You saw Columbus. He turned around and went back. Good job. And then Magellan is the blue one, and he made it all the way around and got killed in the Philippines. Sucks for him. To nitpick, he actually got killed in there. Made it all the way into the Philippines. Anyway, moving on. And then the English sort of were the first people to really start to study the science of the oceans, and they did this in a way to try to maintain their, the English Armada's dominance. James Cook, there's a couple really famous movies about him. He took 3 major scientific voyages. He spent a lot of time in the Pacific. He always had a shipboard scientist who also served as the doctor for the crew. Ironically, he was killed in the Sandwich Islands. There's rumors that he was eaten. I don't know how. Oh, the Sandwich Islands are now called Hawaii. They weren't really the Polynesians in that part of the world. Hawaiians were not actually cannibalistic, so the idea that he was eaten is probably not true. And then Right in the same time period, the final major invention for exploration is created. John Harrison invents the marine chronograph. Chronograph is basically a watch. Clocks prior to the chronograph he invented couldn't go to sea because they involved like the pendulum swinging back and forth in order to keep time, and on waves that didn't work. The chronograph that he made uses springs and watch gears, and it kept time. And the reason why time is important, if you know what noon time is of the place you left, and you know what local noon time is of where you are, you can calculate the distance between the two and thus get longitude finally. So between these developments of Pythagoras and getting circumference for Eratosthenes, and finally the chronograph from John Harris, we have the real tools for navigating the world, and it's not just a GPS unit. These are Cook's voyages. You can see Cook got around, especially in this part of the world. Really did a lot of study. Was the first European to visit Easter Island. He really traveled the world in, the 12 years or so he was traveling. And the study of the ocean continues. Oceanography is more high-tech than ever before. Sonar, robots, satellites, computers, remote sensing is a wildly important science. Despite that, and all we've done, we still, again, I've said this before, but I'll say it again, we know more about the surface of the moon than we do the bottom of the ocean. It's basically impossible to go a month without discovering a new animal at the bottom of the ocean, including ones we thought were extinct, like the coelacanth. So, still more stuff to know. And as the age of exploration sort of turned into the age of science, especially oceanography as a science, we'll talk about the Challenger expedition in particular, we need to talk about the scientific method. So, scientific inquiry became more and more formalized as the years went on, and we use what's called the scientific method. I don't like the way it's called the scientific method, as if there's one. It's not as concrete as people think, but it is an organized process that tests predictions and tries to determine what's going on in the natural world around us. This is a chart you've probably seen 100 times in every science class since you started, science class. Basically, there's an observation with this stupid analogy of Newton. An apple fell on his head, which, by the way, didn't happen. In terms of modern science, we don't really do observations anymore, but we go and we do background information. For those of you who are in the research class, it should be, your annotated bibliography. That's your observation. You find out what's known so you can figure out what's not known. Then you make a hypothesis. It's basically, what do you expect is going to happen? Then you test it and experiment. And if testing goes well and you develop a model mathematically and you clarify your original hypotheses, as there's a lot of back and forth between these two, this really should be like this, but many times. Eventually we come up with theories. And theories are, well, let me talk about that in greater detail in the next slide. One of the things that's going on is and it's a concern of mine as a scientist because it's kind of become politicized. Science never really talks about facts. We talk about probabilities. We don't talk about truth. We talk about what we know. And if you listen to scientists talk for more than 10 minutes about even things they're wildly knowledgeable on, we tend to hedge our bets. We use words like, well, it is most likely that, and it is probable that this is what's causing this to happen. We never just use simple language like this is or this isn't. And that's because, the nature of science is we're always ready to refine our ideas with new information. But with a theory, and this is from every theory from evolution to atomic theory to gravitational theory to plate tectonic theory, which we'll talk about in this class, a theory has 3 requirements. Number 1, it must be falsifiable. And falsifiable is a strange thing that I don't know if you've talked about in your other classes, but it must be possible to prove it not true. For example, with atomic theory, the theory was that all matter was made out of atoms. And this was falsifiable because it is possible that it wasn't made out of atoms. So the same thing with evolution. We believe that life has evolved in a certain way. It's possible to falsify evolution by finding, things that would counteract that. For example, if we found like a bunny fossil in the Cambrian, that would really throw off what we know about evolution. There also must be a body of evidence. So many experiments by many people over extremely long periods of times would be the body of evidence. And it must be testable, meaning it must make predictions. All of the theories I mentioned all have testable predictions that they can make. This is happening a lot with quantum theory right now. One of the problems we have with quantum theory is technology is not making it falsifiable, but that's a whole other issue. And that's where we're going to stop on this video.